Dear students, today I will start the next topic, hydrology, in first chapter. Hydro means water and hydrology means the branch of science that deals with the processes governing deletion and replenishment of water resources over and within the surface of earth. The cyclic movement called hydrologic cycle of water rotates water from the sea to the atmosphere by evaporation and then from there by precipitation to the earth, and finally through streams, rivers, etc. back to the sea. Here in this simple figure you can see sea and land. During summer season, due to the heat energy in sunlight, the water in the sea gets evaporated, and after evaporation it is added to the atmosphere. In the atmosphere, the vapors get condensed and they shower the water onto the land in the form of rain. Not only in the form of rain, but sometimes in the form of snowfall, in the form of dew, etc. The water that falls on the land may be stored on the earth's surface, as in case of lake, pond, pits, etc. Or the water may flow on the surface of land and maybe joining the sea once again. Also, some of the rainwater will be absorbed by the land, and that absorption process is called as infiltration. The infiltrated water adds to the water table. Later on, that underground water may be used for various purposes. Some of the water on the land may be absorbed by plants, may be consumed by animals, and may be absorbed by buildings, etc. So this completes a water cycle. The water that flows on the surface of land is called stream, river, etc. Altogether, the water that leaves the land and flows into the sea is called as outflow, and the water that leaves the sea and comes onto the land is called as inflow. We can write an equation relating inflow and outflow. Always inflow is equal to outflow plus change in storage. It means that inflow will not be always equal to outflow, because some of the inflow water will be stored on the surface of land or under the surface of land. So when water is added to such storages over the earth surface or under the earth surface, there will be change in storage level. So inflow will be equal to outflow plus change in storage. This equation written here is called as hydrologic equation. The main source of inflow is precipitation, that is condensation of water, that includes rainfall, snowfall, mist, dew, frost at the gauging site. The gauging site means the site at which inflow is measured after all losses. Now we will study the sources of outflow in detail. First one is surface runoff. It is the portion of the precipitation which appears as surface flow at the gauging site after all the losses. Let us consider certain site here. When it rains, the water will fall on this hill and that will flow down and fill this depression here. When this depression is filled completely, then the outflow from the depression will start and the next depression will also be filled. If that depression gets filled, then the outflow starts. So the water that flows on the surface of the land is called as surface runoff water. So we can call this as surface runoff. This is depression, and inside the depression water is filled now. This is rain. Next source of outflow is evaporation. It is the process by which water from liquid or solid state is converted into vapor form. Say after the rainy season and winter season, a summer season starts. Due to the heat energy present in sunlight, the water stored on the surface of land gets evaporated. That evaporation may be shown like this. The third source of outflow is infiltration. It is the process by which water enters the surface strata of the soil and makes its way downward to the water table. When water starts to flow on the surface of land, slowly the water will be absorbed by the soil, and also from the storage the soil will start absorbing the water. The absorption of water by the soil is called as infiltration, and the water is called as infiltrate water. Next source of outflow is transpiration. Transpiration is nothing but loss of water by plant through the stomata. You all have studied that in your 7th standard, 10th standard, and I hope even in 12th standard also. Let us assume a tree here. The tree absorbs water from the soil. When the water in the tree becomes excess after the usage, the excess water will be lost through the stomatal pores present beneath the leaves. The process of losing the water by the tree is called as transpiration. So these vapors will be added to the atmosphere. Next source of outflow is interception. We all know that plants and animals need water for their survival, and the maximum percentage of their body is made up of water. And also we know that the buildings absorb the water that is present in atmosphere. Such water remains as a storage in the plants, animal bodies, and the buildings. This storage is called as interception. This stored water is subsequently lost by means of evaporation, and this loss of water will not contribute to the surface runoff. Now we will study the different forms of storages. First one is depression storage. Depression storage is the quantity of water stored in small and large depressions, filling them to their overflow level. the quantity is lost gradually due to evaporation, etc., without contributing to the surface runoff. We'll refer to this first figure here. I had shown depressions here and here. During rainfall, these depressions get filled. After getting filled, if rainfall continues, then the water from these depressions will flow out. That will result in surface runoff water. But when the rain stops, no water will be added to the completely filled depression, and hence no water will flow out. So whatever the water is stored here, because of the heat energy in the sunlight, will get evaporated, and that will not add to any surface runoff water. So that you can see here in the second figure. In this figure you can see the water flowing out of the depression as long as rainfall is there. Once the rain stops, the outflow ceases and the water in this depression will get evaporated. Here I have shown two neighboring depressions. If one depression is filled, the outflow water may go and be stored in the second depression. If that also gets filled, then there will be outflow. That will result in surface runoff as long as there is rainfall. But if there is no rainfall, definitely there will be no surface runoff water because of these depression storages. Next we are having detention storages. Some of the water is accumulated on the land due to precipitation. The overland flow contributing to the runoff is possible if there is finite depth of the flow over the surface. The volume of the water corresponding to this depth is known as detention storage. Detention storage. Some of the water is accumulated on the land due to precipitation. The overland flow contributing to the runoff is possible if there is finite depth of the flow over the surface. The volume of water corresponding to this depth is known as detention storage. Now consider this figure. Here I have shown a channel and this is precipitation occurring. So due to this precipitation, water gets accumulated in this channel, but the water that gets accumulated here will not start to flow immediately. The water here starts to flow only when there is certain depth of water. So to make you understand in more better way, I will consider a cuboidal shape of channel. So the channel is like this. And say inside this, there are some hurdles. Now due to precipitation, the water is added here. So that water may be up to this level. When water is up to this level, this water will not flow. The water starts to flow only when the level of the water becomes more than the height of the hurdles. So when water just starts to flow outward, that means when the water level has become equal to the hurdle level in the channel, at that time how much water is there inside this channel, that is called as detention storage. That is called as detention storage. If I consider a channel of the dimensions shown here, and this is the hurdle level, if water crosses this just, then it will start to flow out. Then the water stored in this channel at that time is nothing but volume of the water with the flow depth. With the flow depth. Flow depth means what? The depth of the water when the water just starts to flow. So here you can calculate detention storage as 5 into 2 into 3 meter cube. That is 30 meter cube or 30,000 liters or 30,000 liters. This is nothing but flow depth. This is channel height. This is channel height. Now we will study what is mass curve. Mass curve is a plot of cumulative volume of water that can be stored from a stream flow versus time in days, weeks, or months. The figure below shows a mass curve. The maximum intercept between line AB and mass curve is known as reservoir capacity. So here the cumulative flow is shown on y-axis and the time in weeks is shown on x-axis. Cumulative flow versus time graph is plotted here, and this graph of cumulative flow versus time, maybe in weeks, months or days, is called mass curve. If we draw a tangent to the initial part of this mass curve, the maximum intercept between line AB and the mass curve is called as reservoir capacity. So to understand what is cumulative flow, we will consider one simple analogy. Let us consider a pipe here with a tap fixed. And say here is a water tank. Say here is a water tank. Now if tap is made on, then water will start to get collected in this tank slowly. Say the water flow here is 20 liters per minute. 20 liters per minute. That means in 1 minute 20 liters of water will be collected. After 2 minutes, how much water will be there? There will be 40 liters of water getting collected. So first minute 20 liters, second minute 40 liters. Third minute 40 plus 20, 60 liters. If the flow rate is changed, say now I make it 10 liters per minute. Then in fourth minute I will have 60 liters plus 10 liters, that is 70 liters. So water is going to get collected in the tank in this way. So the water that is getting collected in the tank is called as cumulative flow. Is called as cumulative flow. It can be measured in meter cube or in liters. So for this information, for these observations, if for these observations we plot a graph, how it would appear? First minute, second minute, third minute, fourth minute. Say 20, 40, 60 and 70. 20, 40, 60 and 70. It is in liters here and the time here is in minutes. So 20, 40, then you will have 60 and after that you will have 70. So if I go on changing this tap position, then at different time intervals, different amount of water will be collected. That is called as cumulative quantity of water in the tank. So instead of this tap and pipe arrangement, we consider a stream or a river and then a reservoir, then it becomes mass curve. Then this graph becomes mass curve. The unit used for storage is either cubic meter or day second meter. A day second meter is the flow at the rate of 1 meter cube per second. For 1 day and is equal to 60 into 60 into 24. That is equal to 86400 meter cube. The capacity of the plant is based on the storage capacity of reservoir. Definitely, how much energy can be generated by a plant, that depends on how much water is stored in the reservoir. If the reservoir can give water for long time to the generator to operate, then generator will keep generating power. Therefore we can say the capacity of the plant is based on the storage capacity of reservoir. If reservoir is small and can hold less water, then after the water is finished, reservoir cannot give any water to the plant and hence the plant cannot generate any energy. So the energy generated in a certain time period will be definitely reduced. The water stored, these are two definitions here. The water stored in dams is called ponds. You all have heard about Almaty Dam, Navilu Tirth Dam, TB Dam, that is Tungabhadra Dam, etc. How much water that is stored in dam is called as ponds. Different dams will be having different ponds, and water stored in upstream reservoir is called storage. Now I would like to tell you what is upstream reservoir. Let us say this is a river and the dam is constructed here, and the water gets stored here. If a reservoir is constructed here to store the water so that it can be used for generating power by using a tunnel, then this reservoir has to be filled by diverting the river into this reservoir. Not complete river, but some part of the river, maybe by construction of canal. Since reservoir is there before the dam, where the river is bringing water into the dam, such a reservoir is called upstream reservoir. Upstream reservoir. After the dam, the water flows now. This water flowing here is called as downstream. If from here a canal is constructed and the water is stored for generation of power, then it is called as downstream reservoir. Now you can understand the head of upstream reservoir, the head of the power plant which are fed by upstream reservoir is more, and the head of the power plant which is fed by downstream reservoir is less.